You know what I miss? Factoring trinomials.
Ah, me too. If only there was a way... Hold up. Are we solving systems using quadratics?
Why, yes, Miss T. Yes, we are.
Man, I bet we could apply factoring here. Let's find out.
Okay. So I'm pretty sure you can use substitution and elimination to systems that involve quadratic equations. Just like this one right here.
Ooh.
So this one, even though it has a linear function as part of its system, it also has a quadratic one right
How
there.
do you know it's quadratic?
Because this term right here has an exponent of 2.
Ooh.
Therefore, it's a quadratic equation. Even though y only has a power of 1, because that x has a power of 2, this thing's already default quadratic. So if we're going to choose to solve this, while we could use substitution or elimination, my personal recommendation here is substitution. And when you choose to use substitution, you want to choose a variable that doesn't have an exponent of 2. So I'm not going to choose x because it has an exponent of 2, even though it has an exponent of 1 there. Just ignore the x's. But I could see that y has an exponent of 1 there, or y has an exponent of 1 here. So I'm probably going to go with one of those two to isolate in this process of substitution.
Okay, let's give it a try. So as Mr. A was saying in this system, we have two equations. Equation 1, equation 2. And we have to decide to isolate one of those variables. No, we are not going to isolate for x because of that exponent of 2. We are going to isolate for y. Now, when we choose which y to isolate, I tend to look for the y that has a coefficient of 1 or negative 1 if possible, because it just makes things a little bit easier. So I'm going to isolate for y in equation 2 just because it has that simpler coefficient. So isolate for y in 2. Now notice if I want to isolate for y in equation 2 here, all I really have to do is add 3 to both sides. But because I know I'm going to be subbing that information in to my equation 1 later on, I'm also going to work and simplify that as well. So I'm going to just start by distributing that negative to both the x and the 1. So I get negative x minus 1. And then I'm going to move the 3 over. Add 3 to both sides. So y is equal to negative x. And if I have negative 1 plus 3, that is positive 2. So now that I've done this, sometimes I like to rename this guy equation 3 because I know at the end of the day, once I get a value for x, I need to sub it in to solve for y. And this equation is super handy because y is already isolated. So that just makes things a little bit easier down the road. But now that we've come up with this equation 3, we've isolated for y, we're going to plug in or sub that value for y, negative x plus 2, into 1. All right, as we do that, we have x squared, we have 3x, we have minus 8, we have minus 2. Ooh, where'd my minus go? Minus 2. Whenever I sub this in, I'm going to make sure I do that so in brackets, just because sometimes if I had like a negative in front of it, that 2 wasn't there, I need to remember that that negative 2 applies to that whole value of y, so both that negative x and that positive 2. So always sub it in using those brackets. I'm going to start by simplifying here. So minus 8, so I get positive 2x minus 4. I'm going to collect like terms, so x squared minus x minus 12. And as I could see, I could solve this using factoring. So as I factor this here, I end up with x minus 4 and x plus 3, because that negative 4 and the positive 3 multiply to negative 12, and those add to negative 1. And I'm going to solve for each of these binomials as if they were equal to 0, because if we have two things multiplying to 0, one of them has to be. So here we get x is equal to 4 and x is equal to negative 3. So you could see we have two possible values for x here, which means if I want to solve for y, I might have two possible values for y as well. So what I'm going to do is I am going to, maybe I'll do it over here. I'm going to sub in my first solution, my x is equal to 4, into equation 3 to solve for that corresponding y. So I have y is equal to negative, and then 4, plus 2. So y is equal to negative 4 plus 2, y is equal to negative 2. And I'm going to do the same thing, but with my other value of x. So I'm going to sub x is equal to negative 3 into that same equation 3 where I already have y isolated. So I get y equals minus x, so minus negative 3 plus 2. So y is equal to 3 plus 2. Y is equal to 5. So typically when we are expressing our solution, we would do so. Make sure that our x's and y's are corresponding. So this guy here matches up with this y here, and this x matches up with that y. So we need to make sure that they correspond nicely. I'm going to write or and have negative 3, comma 5. Theoretically, if we knew how to graph quadratics, we could also find this out via graphing. We're not really quite sure how to graph these in grade 10, but just so that you can see what's going on here and acknowledge that there are some similarities between solving algebraically and solving graphically, even though we might not be exactly sure how to do that quite yet. X plus 1. So we can see there's two intersections, and those are the values that we got. So kind of cool to draw those together.
Because we have multiple solutions, we can refer to there as being a collection of solutions. And in math terms, a collection is known as a set. So this collection of solutions is a solution set. Pretty key term there. Which means we're going to invoke some notation we've seen way back in the day when we talked about sets, aka set notation. And so since our possible solutions were these two values, we're going to write this in the following way. We're going to say that our xy solution is an element of our solution set. And in here, we'll put all of our solutions. One of those solutions was the point where x was negative 3 and y was 5. And the other was the point where x was 4 and y was negative 2.
So we will always be making sure that our final answers display our solutions as such. Okay, now let's take a look here. For this example, why don't you pause the video and give this next one a try. Did you do it?
You better have done it. Or have tried.
Okay, so we're going to take a look at this one here. We're going to start by, as always, labeling our equations here. We can see that that top one is quadratic because we have an exponent of 2, but now the exponent of 2 is on my y variable rather than my x. Because my exponent of 2 is on my y variable, I'm not going to be isolating for y in either of the equations. I'm going to isolate for x. And looking at both of these, it's probably equally as easy to isolate for x in either because the coefficient is either 1 or negative 1. Personally, when I have this option, I tend to isolate for x in the linear equation over the quadratic, but you would get the same answer either way. So here I'm going to isolate x in equation 2. So I have x plus y is equal to 4. And I'm going to move that y over, so I get x is equal to 4 minus y. And again, I'm going to denote this as equation 3 because now that x is isolated, when I end up having my values for y, I can sub that in here. All right. Now that I have that, I'm going to sub x is equal to 4 minus y, or equation 3, into 1. So here I have it. I have y squared minus 3y minus 4. And again, when I'm subbing in that value for x, I'm putting it in brackets. And we could see in this particular example why it's so important. Because this negative is going to apply to this 4 and to this negative y. If I mistakenly did not include those brackets, I could see that it apply to that 4 just the same, but I would end up with this negative y, which will change my final answer. So please make sure when you sub it in with brackets. Okay, y squared, negative 3y, minus 4, plus y is equal to 0. We collect our like terms. We get y squared minus 2y minus 8 is equal to 0. And if this is the point in which we can factor, the point you've been missing.
I miss factoring.
And we end up with minus 4 and positive 2 being the factors of negative 8 that add to negative 2. Knowing that those two binomials multiply to 0, one of them has to equal to 0. If this first one equals 0, then y would have to equal positive 4. And if the second one equals 0, then y would have to equal negative 2. Now that we have our values for y, we need to find the corresponding values for x. And we could do so by subbing these values back into equation 3 that already has our x isolated. So sub y is equal to 4 into 3. Oh, I don't want that lasso. I want this lasso. I'm going to move it over and do these side by side. And then here I'm going to sub y is equal to negative 2 into 3. All right. Ooh, I need to see what 3 is. So I have x is equal to 4 minus 4. And here I have x is equal to 4 minus negative 2. So on the left here I got x is equal to 4 minus 4. Well, that's just 0. And on the right here I have x is equal to 4 minus minus 2. So x is equal to 4 plus 2, giving me 6. And as Mr. A taught us, we need to make sure that we denote our solution as an element of the following set. Now we have one possible solution being 0, 4. And we have the other possible solution as 6, negative 2. So here we are.
Just be super careful when you're putting those points into their xy form. Sometimes the temptation is to put the first thing we found first.
Oh, that's
and
so
the second
true.
Found second, and then write something like 4, 0, just because that's the order we found them in. But x should be x, y should be y. So watch out. We do have one more example for you. Again, do try and do it on your own. See what you can do, see what you come up with. I'm going to draw a quick dividing line here.
That's a good idea.
Separate this work. That'll do. All right. So again, give this a try. Pause the video. And then see what happens. All right. Now I'm looking at this. I'm noting that these are both quadratic. So this is a quadratic equation. This is a quadratic equation. And that's because of this exponent of 2 right there, which will apply to that x when it's all FOILed out. Any poopsilies, I'm looking at this and thinking I probably want to isolate y here or here. Whoa! That y is already isolated, so I'm just going to say it's already isolated in what I will call equation 2 if I label it. So I'll sub that into equation 1. Whoop. And that'll say that x squared plus 2x plus 2y, where y is equal to this behemoth right here, is equal to 0.
Dang.
Yeah, it's a doozy. Or, as we like to say, a doozy. We've got our work cut out for us. There's a bit of distribution to handle here. The 2 will have to apply to this term, because this is all one term, glued together with multiplication, and then the 2 has to distribute to that negative 4 as well.
One thing that you might also be tempted to do, because as you can see when you plug it in, it is quite a doozy. If you would like to, you're more than welcome, as your first step is to simplify equation 2, where y is already isolated. So if you want to, before you sub that in, that value or that kind of expression for y into equation 1, you're more than welcome to simplify it.
Yeah, there's an order you can play with. It's all multiplication through and through. So the order you multiply things in is not so relevant as much as it is that you just do it at some point. So 2 times 1/4 x minus 2 squared will be just 1/2 of x minus 2 squared. And then 2 times -4 is that. Woo! At some point we're going to have to figure out what x minus 2 squared is. If you remember how to quickly expand or quickly square binomials, you can jump to that. If you need to do some work on the side, do some work on the side, where you say that x minus 2 times x minus 2 is x squared minus 4. Well, let's do it slowly. 2x minus 2x plus 4. And we know it's a scrap work because it's on its own little cloud. And then we can say that we've got x squared plus 2x plus half of x minus 2 squared, which is all this, minus 8. Note we're still keeping this equals 0 here the whole time. We're not just dropping it and turning an equation into an expression. That'd be a big no-no. But let's proceed. Distributing that 1/2. Gives me that. And then collecting like terms. 2x minus 2x is nothing. 2 minus 8 is -6. Well, that got pretty compact pretty quickly. And then factoring wise, I'm going to probably get rid of that and factor out 3/2, but divide both terms by that.
Nice work pulling out that GCF.
Thanks. I'm going to take 6 and divide it by 3/2 as well, which I guess is the same as 6 times 2 over 3, which is 12 over 3. And that's again in my scrap work cloud organized over here.
12 over 3, that's just 4.
Yeah. And then I can finally factor this into its 2 components.
Ooh, difference of squares, TBH, that's my fave.
You know what? I don't really care what I'm factoring as long as I'm factoring.
That's fair.
I've just missed it so much. Well, here we get 2 possibilities. Either x minus 2 is 0, or x plus 2 is 0. So x is 2, or, x is -2. And we can sub those into the other equations. Or equation, whichever it was. Yep, might as well sub it into equation 2 because that's where y is already isolated. So I'll do this slightly different. So if x is equal to 2, then y is equal to 1/4 of, what was it, x minus 2 squared minus 4. So 2 minus 2 squared minus 4. And then I can evaluate that. It's 1/4 of 0 squared minus 4. And that's just -4. If x is -2, y is 1/4 of that same equation, but subbing in the -2 instead. So 1/4 of -4 squared minus 4. And, well, 4 squared is 16. Quarter of that is 4. Minus 4 is 0. So the points I get for my solution are the point where x is 2 and y is negative 4, and the point where x is negative 2 and y is 0. That is my solution set. Whoop. Boom. Nailed it. Now there is a little bit of practice work for you. It's right over here where it says practice. We urge you to give that a go. You can find solutions on Teams when you're looking for them.
We will also be going through these questions or answering questions about these in class. So rather than having a worksheet on this, you will be working on this practice work.
Yeah, and of course, let us know if you have any questions, comments, concerns. But happy factoring.
Oh, it's always happy factoring.